Welcome, Math 1332 class. I'm going to go over a version of the MyLabs Plus test number 3 that was generated for me. And this is to help you study for the financial test coming up. Okay, over chapter 7. Okay, so we'll begin with the first question. There's 20 questions that I want to go over. And so let me enlarge this and just go over the first question. So this says, suppose that the local sales tax rate is 3% and you purchase a car for $22,500. So how much tax is paid and what is the car's total cost? Okay. And so, of course, these are just answers that have been generated so we can double check our work when we're done. Okay. And so when we take this test, this financial test, there are a list of formulas I've asked you to print, and I just have some things written on my sheet as well. But generally for this test, I will want you to identify the formula that you use in the problem to solve it. And then on your paper, I also want you to put in your substitutions. So what are the numbers that you plugged in for the different variables? And that way we can identify the unknown, the letter that you're solving for. You are allowed to use the calculator, the TI-30XS calculator, okay? And so I had sent you an email about this. Is when you take this financial test, one thing you want to make sure that's important is this key, this N over D key. So I'm going to turn this on. And you do want to make sure that when you press that it is set up similarly as a numerator over the denominator. And instead of having the slant fraction bar, you want that straight horizontal fraction bar. And so to do that, if it's not already in that setting, it's easy to change. You would just go to mode and make sure it's under math print. If it's not in math print, that means it's classic. So if I hit enter and I just went down with these arrow keys and I hit enter, you can see it changes this to classic. So then when I go back to my, see how it's got that slanted line? It's better to have this horizontal line when you're doing this kind of work for the financial test. So you need to make sure it's on the right mode. So go back up to mode, use this down arrow key, and then make sure you right arrow key, hit the math print and hit enter. Okay, so then this is floating. This is like how many decimal places do you want recorded in your answers? And so usually it's good to leave it as float. It will record the max allowed in the program to see on the screen. And so really these are just the two that we need to work with for now. And so I'm going to hit enter, so it saves that. And then when I go back to the ND key, you see it's available as needed. The other thing is there are a lot of exponents. You see on this formula sheet, see this is an exponent raised to the NT. So the number of times we're compounding per year times the amount of time. And so sometimes it's RT, this is a rate times time. And so these are little exponents. So to activate the exponent, what we use is this caret key. I call it a caret key or a hat key. And so this is a key that we use to activate the exponent. So you'll see me using that today on this test review. The other thing is when things are compounded continuously, we use this transcendental number E. It's a value about 2.817 or 2.718, but it's a value of approximately 2, and it's a transcendental number, and so it's used for annually compounding. And so to activate the E, we need to press the second button, and then this LN key. You can see right above it, there's the EDX. So if I do second, and then I hit that EDX key, I have to turn it on, but that second, and then the LN key. And let's just say I want the value of E, it was 2 point something. I do the first power, let's just say, and I hit enter. See, there's the value, 2.718281828, okay? That's the value of E. All right, so those are the main ideas that I want to consider for now. Okay, so another thing too on these formulas, when we use these formulas, just ideas to differentiate ideas on the planning. See how this formula here has a negative nt power? So that's a negative exponent, and oftentimes negative exponents mean that values can be rewritten, relocated, and so this actually can be relocated in the denominator, this value of 1 plus r over n. And so you see your teacher here has rewritten this, or p is equal to a over this quantity. And then once I moved that to the bottom, the denominator relocated it, I took off, you have to make sure you take off that little negative. And so this is equivalent. Both of these are equivalent, okay? And so just keep that in mind. And I notice your book also tends to make use of this. All of these are both equivalent. Just if you use this one, you have to make sure you put that little negative, okay? So when I show my work, I can do it both ways, and you can decide how do you want to use that, okay? All right, so we'll talk more about these as we come along in the review, okay? So have this sheet available because you can use this while you're taking the test, as well as your review. Your review, you can have that out and make reference to that, okay? So now going back to this problem, let's go back to this problem, get a pen out. So we've got the costs. I'm also gonna glasses on and see. See, we've also got the small font here. So we've also got the cost of the car. So I'm going to take the 22,500 times the tax rate, which is at 3%. Okay. So when we work with the tax rate, we want to move our decimal places two places to the left. Okay. So on number 1, I'm going to show that we have the 22,500, which is the cost of this item. So this was a car. So I should say car costs. And we want to multiply it times the percentage, which is 3%. Okay, so what you can do is you can either move the decimal 2 places to the left, or if you want, you can, because percents, definition of percents is parts per 100, you can actually divide it by 100. So you can actually do 3 divided by 100, okay? And if you don't see the decimal point, it's located at the back, right? So you either move it manually 2 places to the left, or you take your calculator and you do 3 divided by 100%, which is 0.03. So this 0 is important, it's proper, but you don't really need that. So I just put 0.03. You don't need that 0.03, okay? And so we would show that we take the cost of the car times this tax rate, which is 0.03, okay? And then you are allowed to use your calculators on your test. So if you were doing this problem, you will have a problem like this on your test. So what you need to show on your paper for full credit is just showing me that you're taking 22,000 times 0.03, and that would be sufficient. You don't have to write, this is the car cost, this is the tax rate, okay? So I'm just doing that so the person can understand what values I'm using. So this is 22,500 times 0.03, which gives us $675. Okay. Now, just for the practice, if I didn't have my calculator and I were doing this by hand, I would multiply 3 times 0, 3 times 0, 5 times 3 is 15, carry my 1, 3 times 2 is 6, plus 1 is 7, 3 times 2 is 6, and then I count my decimal moves. And since I have 2 decimal moves, then I've got to move my decimal 2 places this way. So then that still gives me $675. And that, what is that? That is the sales tax paid. Okay. Okay, now as far as the total costs, the total costs will be the car's costs plus the tax. Okay, so our total cost is going to be, the cost was 22,500 plus the tax was 675, and these are units or dollars. So then when I add that, and also when you show your work for that too, it's probably better for you to show it horizontal. This is horizontal, so it's probably better for you to stack it. Most of y'all will probably stack your work. So I'll take 22,500 plus that $675, and then we add that up. So if I 0 and 5, 0 and 7, 6 and 5 is 11, carrier 1, 2 and 1 is 3, 2, and then it's 1, 2, 3, comma. So we should get 23,175. And of course, you're allowed to use your calculator. So I was just adding just to show you that. And then when I add 23,175, okay. All right. So that's, so on your test, when you show your work, this is showing your work. Okay. This is showing your work. Okay. And then you would look for your answers on the computer, and then circle your choices or choose your choices on the computer. Okay. And on the computer, they may or may not ask for both content. They might ask like just the first question. They might ask on your answer choice the amount of the text, or if they ask for both, they would have both in a multiple choice, like choice A, they would have 2 answers stacked. Okay, so they'll either ask for both or just one. Okay, but the review will help you. You can do that on the review. You can do this on your tests. Okay. Okay, now problem number 2. Let's go to number 2. It says that an exercise machine will, with an original price of $970, is on sale at 24% off. What's the discount amount? Okay, and then what's the exercise's machine sell price? Okay, so they have a discount amount and then the sell price. Okay, so for this problem, the work that you would show on your paper is you would take the original price of the machine, which was $970. So that's the exercise machine. Exercise machine, so that's the original price. And then the discount rate was 24% off. So again, 24%, which is, oops, sorry, which is 24 divided by 100. So you either move your decimal 2 places to the left manually, or you use your calculator and you say 24 divided by 100, which is 0.24 is your discount rate. So you want to multiply 970 times 0.24. Okay. So again, I'm going to show you how to do this manually, just to make sure you want to know how to do this manually, but we were allowed to use our calculator. Okay. So 4 times 0 is 4. 7 times 4 is 28, and carry your 2. 9 times 4 is 36, plus 2 is 38. Okay, and then when you do your second row multiplication, you either leave this spot vacant, or you exit out, or you put a 0 there, because you're doing your second row multiplication. So when you start your multiplication with 2 times 0, that recording actually starts here. 2 times 0. And I also like to scratch these out. I've used those already. So 2 times 0 is 0. 7 times 2 is 14, carry your 1. 9 times 2 is 18, plus 1 is 19. And then I'm gonna add everything up. And so I have 0, 8, 8, 9, 10, 11, 12, carry the 1, 9, 10, 13, carry the 1, and then that's a 2. And then I count my decimal moves. I have 2 decimal moves. So I have 1, 2. Okay. So I'm at $232.80. And when I check down the calculator, 970 times 0.24 is $232.80. So on the calculator, it doesn't show the 0 in the back, and this is the nearest cent. So this is not saying 8. This is not 8 cents. This is 80. Okay, that's the discount amount. Okay, and then the other question was, well, what's the sell price? So for your sell price, you've got to take the original price of the machine minus discount rate. So you do the original minus discount. Oh, the machine was $970 minus a discount, which is $232.80. Okay. So again, I'm going to show this because it involves borrowing. Okay. And we are allowed to use our calculator to double check that, but I'm just to show you the borrowing. So 0 take away 0 is 0. 0 take away 8. Notice how we cannot do that, so we have to borrow. But look how this is also 0, so I can't borrow from that. So I have to go all the way to 7, decrease the 7 and make it a 6. But now this 0 becomes a 10, and so now I can borrow now. So now I decrease that 10, make it a 9, and now this 0 is a 10. Yeah, so 10 minus 8 is 2. Bring down the decimal point. 9 minus 2 is 7. 6 minus 3 is 3. 9 minus 2 is 7. So I should get $737.20. So let me just double check down the calculator. So I have 970 minus $232.80. Yep, it's $732.20. Yeah, so that checks out. Okay, so on your tensor, you show me that you have to take 970 minus $232.80. So you're conveying to me, what did you do? What did you type into your calculator? So you got to review that to me, okay? All right, so that's problem number 2 there, okay? So now let's go to problem 3. Okay, so 3 says that the circle graph shows a breakdown of spending for the average household, and it was using 365 days worked as a basis of comparison. And it says, what percentage of work time does the average household spend paying for housing and household operation? So paying for housing and household operation counts for what percent of work time? And then they want you to round to 1 decimal place as needed. Okay. All right, so what we're gonna do is, if you take a look at the circle, now my circle, my printer didn't come out. It didn't come out such a great printout because it didn't show the sectors and the printing. And you can see how I had to write over this because this came out really light. Like this is saying medical care. But what I did do is I took all these numbers. I just went clockwise, and I added all those numbers up. So you can see I started with 52, and then I started with 30, and then I went to 21, all the way through until over here, which the last thing I added was 36. And I did add them up, and it did give me the 365 days. Yeah, and I was just making sure, because they did tell you that we had this is like the idea of your base. They did tell us that we had a base of 365, but they don't always tell you that. Like when you take your test, they may not always have that base here, and so they'll have your circle, so you'll have to go through and count and do a count to make sure what the base is. So even though, and also I was just double checking when I added all these up, I did get 365. Okay, now we want the part about the household, so we actually want this percentage right here, household and household operation, which is reflective of this here, the 64 days. Okay, so then on my paper, this is what I'm going to write. The formula that I'm using is I'm using the amount over the base times 100%. Okay, now on here, I don't necessarily see that as one of our choices necessarily here. And so you can write that on your practice test here, amount over base times 100%. And for us, our amount is reflective of that household, paying for household and household operations. So I can put that here, paying for housing and household operation. Okay, over my base, which you saw me double checking and counting, which was 365 times 100%. And now you saw me looking at that number there, and you saw that number I said was for me in my particular problem. We were talking about this subject and or that amount, and it was 64 days. So then I would write 64 over 365 times 100%. Okay. So then when I type that into my calculator, turn this on. So I just do 64. I type. So do the 64 divided by, and the count was 365, and then times 100. Okay. And if you wanted to go across, you could also do this. If you wanted to go across and then divide, we would get the same answer. If you wanted to do 64 times 100 and then divide it by 365, that would be okay also, and you'll see that we get the same thing. So we get 17.53424658%. And then remember they said round to, what did they say, round to the 1 decimal place. Okay, or they could say round to the tenths, round to the tenths, or round to 1 decimal place, which is right here. That's the tenths place. And that's 1 decimal place. So you look at the number to the right, is that 5 or more? Is that neighbor 5 or more? No. So this stays the same. So this is 17.5%. Okay. And then I do have the answer you could check. You can see it's 17.5. Okay. All right. So on your paper, when you're doing this problem, okay, so your work, well, here's your formula. So put that down on your paper, amount over base times 100, and then do your substitutions. These are your substitutions, okay? And then this is your exact. So I want your exact on your paper, and then you go to your answer choice, and then you select depending on what they're asking you to round to, okay? But your teacher wants your formula, substitutions, exact value, and then on the computer, this is on your template on your work, and then on the computer you select the right answer. Okay, so that's number 3. Okay, now let's go to number 4. So this says that the bar graph shows that life expectancy, the number of years newborns are expected to live in a particular region, has increased dramatically since ancient times. Find the percent increase in average life expectancy of the region from the Stone Age to 2016. Round to the nearest integer, which is the nearest ones place or the whole number. Ones place or the whole number for integer. Okay, and so they're taking Stone Age to 2016. So here's Stone Age right here to 2016 right here. Okay, and you can definitely see it why they say it's a percent increase, because it went up. If it had been a percent decrease, it would have been going down, but it went up. Okay, so that revolves around this formula, percent change. And so the percent change, either you're going to have a decrease or an increase. This one was an increase divided by the original value times 100. Okay? And then on the increase, we'll do a subtraction. So on the increase, we'll to find the increase, I'll subtract those numbers that we saw here. This 2016 number for me, which was 70, minus the Stone Age number, which was 28. Okay. So on my paper, when I do number 4, so the formula is, it's a percent change formula. And if you want, since we know it's an increase, instead of putting an increase or decrease, if you want to just put increase, that would be fine, over the original value times 100%. And so for us, the increase, we're subtracting that 70 minus that 28 times 100%. And then the original value is what it was when it first started, before I did the change. So the original value would be the Stone Age was the original value. What it started, what was that? What was it at before the change, which was 28. Okay. So then I'm going to do my subtraction in my calculator. So I'm going to do 70 minus 28, which gives me 42. So I'm doing 42 divided by 28 times 100%. Okay. Okay, so 42 divided by 28 times 100% is 150%. Okay. If you wanted to go across, that would also work. If you wanted to do 42 times 100 and then divided by 28, that would also be okay. You would get 150 as well. Okay. All right. So on your tests, when you show your work, remember your teacher wants your formula, and this formula is on the formula sheet. Do your substitutions, okay, and then you type everything in. And this one didn't have an exact. This one didn't have another like exact, and then you have to round off. This one just terminated on its own. But if you did have decimals and you did have to round off, they wanted you to round to the nearest integer. So remember, integer is the ones place value, or the nearest whole number. Okay, so like if you had, let's just say you had, I'm just making this up, let's say you had 169.28476, something like that. This is the ones place, the whole number, and then you look at the right, that 5 or more? No. So that would just become 169%. Okay, or what if you had 163.8294%? And you're rounding to nearest ones place. This is the ones place or the nearest whole. And you look at the right. Is that neighbor 5 or more? Yes, it is. So you add 1 to that. So now that's 164%. See that? So that's nearest integer. Okay. Whereas on this previous one, over here they said round to 1 decimal place. That's the tenths place. So you have the ones place, and then you have your decimal, the and then you have tenths, then you have hundreds. So they wanted 1 decimal place, which is the tenths. So then you look at the number to the right, its neighbor. Is it 5 or more? If it is, you add 1 to this. If the neighbor is not 5 or more, then this number stays the same. Okay, that's 1 decimal place, that's tenths place. Okay, now let's look at number 5. So a sofa regularly sells for $730. The sale price is $657, and they want you to find the discount rate. Find the discount rate. Okay, so we do have a formula on our paper for discount rate. It's the original price. So originally the sofa was $730, and then you have the new price, which is the sale price, which is $657, and then you divide it by the original price times 100%. Okay, so I'm going to write down that formula on my paper. So discount rate equals the original price minus the new price. And if you want, you can call it the sales price, right? And then you're going to divide it by the original price, and then times 100%. Yeah. So for us, the other thing is under original too, sometimes books will use regular, take the regular price. So if you want to put that, you can. Regular and sales prices, that helps you. So here, if you want to do under new, you can put sales. That would be okay. And here, original, you could put regular. That'd be okay, because those are words that you see that your terminology that your book is using, or that your textbook is using in the problem. So that would be fine. Okay. Right. So the original was the $730 minus the new price was $657 divided by the original, which was the regular price, $730 times 100%. Okay. So when I do this, I do 730 minus 657 is 73 over 730 times 100%. Okay, so 73 divided by 730 times 100. Looks like that just gives me 10%. That's the discount rate. That's your discount rate. 30. You can actually do this in 2 ways here. But if you want to type all this in instead, then you do need the parentheses. And you can see here in the formula that I have I do have the parentheses here. Now on the decrease or increase, I didn't put the parentheses, but I guess I should in case you want to show this other method that I'm going to show you. Because if you want to type all this in one swoop, clear this, you have to put the parentheses in here. So in the numerator, I have 730, take away 657, close the parentheses, divide it by 730, and then times 100. And we should still get the 10%. See that? So what I did was I did open parentheses, and the parentheses are right here above the 8 and the 9. So I did open parentheses. Okay, open parentheses, 730 minus 657, close parentheses, and then I did, see, divide it by 730, and then see, times 100, and I get 10, okay? I just prefer to play it safe, and I simplify the numerator, gives me 73, and then I type that from here on out, okay? And so remember on your paper, you're writing the formula, and then substitutions, okay, and then you get an answer. And again, this one didn't have, if you had a long string of decimals, I would want to see the exact value and before you rounded. This one just terminated on its own. It gave you exactly 10, okay? Okay, so number 6 says, if 610 is borrowed at 3% simple interest for 2 years, so simple interest. So we're in this little space here. See, simple interest, our formulas revolve around these two here. Okay, so let's see. Number 5. And number 6. If 610 is borrowed at 3% interest for 2 years, find the simple interest earned and the total amount to be paid back. So the P, your principal, which is either money being borrowed or money being invested, right? So this is money borrowed, it's 610. The rate is at 3% simple interest. So it's not being compounded repetitively. It's not compounded, it's simple interest, okay? Because if it says compounded, then you go into these formulas once it uses compounding interest, but it's not compounding, it's simple interest. And it was for 2 years. And sometimes it's not always years. Sometimes it might be days, and sometimes it might be months. If it's years, you just use 2. But if it had said days, you've got to use 360. There's a banker's rule of 360. So you have to make the time into a fraction and take the days over 360. And I'll write that down a little bit on the paper to show you. And then if it had said months, there's 12 months in a year. So if it had said months, then you would have had to write a fraction, the months over 12 for your time. So I'll show you that in a little. I'll write that down. So for now, the formula for number 6 is, and this is simple interest, which is I equals to P times R times T. So I stands for interest, P stands for principal, which is money that you borrow or money that you invest, times rate times time, okay? So I is equal to, the principal was $610. And then the rate, remember we said about the rate, the was 3%. So you either was 2 years. So you can just put times 2 years. So when I do this, 610 times 0.03 times 2 gives you $36.60. Okay. Okay. And you can see that matches this here. Okay. Okay. And then they want the total amount to be paid back. So I'm going to write that here, the amount due. The amount due is the principal plus the interest. Okay. So for us, the principal, if I stack this, the principal was 610, and then the interest was $36.60. So you have to line up your decimals. So don't put this underneath here. See, it's the 6 and 3 that gets underneath here. Because see, these are technically zero. So just be careful when you add those up. So 0, 6, 6, 4, and 6. So it looks like it's $646.60. $646.60. Okay, so let's see. So I also wanted to show you. Okay, so I have here, let's see, these ideas that A is equal to P plus I. And I just want to show you this. Interest is equal to principal times rate times time. So PERT, right? And we saw that on a previous problem, right? Interest was principal times rate times time. I think we saw that. Yeah, on the first part is 6. We saw on the first part is 6. I equals PRT. And then I just want to show you about factoring. You can factor out a P from both of these, a greatest common factor. So a greatest common factor is P. So I factor out a P. In other words, I take P and I divide by P. That gives me 1. And then I take this second term, PRT, and I divide it by P. These divide into each other, P goes into P, and I'm left with RT. Okay, so I just want to show you that that's how this formula is coming about. See this formula that we have here? That's kind of where that formula comes from here. Okay. And the other thing I saw in your book, because you see how I have this formula here, the other thing I noticed in your book and your homework problems, sometimes on some of the things they asked for, there was a need to use this formula, but to solve it for P, the principal. So so to do that, they would just divide both sides by this quantity. They would divide this, like if I show you that here, I have A equals P1 plus RT. If you want to solve for P, you would just divide both sides by 1 plus RT. So I show that here, 1 plus RT, and over here, So that gives me P. See that? So that's kind of where I'm getting this from. So I noticed there was on some of the problems in your homework, there was kind of a need maybe to work with that from time to time. Okay. So and this is principal. How much are you borrowing? How much are you investing? Right. And that's what you're trying to find your P. Okay. Um, and so the other thing I wanted to mention is we're talking about time. They for this problem they told us T was years. We had 2 years. So we just this and this is ideas from section 8.3 in your book. Um, and 8.3 was the simple interest. That's the simple interest content. But time could also be days. The number of days over 360, and they use the banker's rule. And time could also be in months over 12. Yeah, so I know in a year there's like 365 days or leap year 366, but they use the banker's rule of 360 is what they use. And other unless otherwise specified, unless they tell you how many days to use, they tell you otherwise how many days to use, 366 or 365, then you use that. But if they don't tell you what to specify, they only say days, and you use the banker's rule, which is 360. Okay. So let's see. Yeah, so I want to do some examples on your test. On your test, you're not sure what example you're randomly going to get selected. You don't know if you're going to get the years or the days or the months. So I just wanted to show you some examples of that. Okay. So let's say that um, what if what if time were 215 days? So this is still thinking about number 6. What if time were given as 250 days, okay, as opposed to 2 years? So then when you apply I equals PRT, trying to find the interest. So let's assume we're still using that 610, right? That they were talking about on number 6. So let's assume that we're using 610, and let's assume the rate is still 0.03 for 3%. But let's say they change the time instead of years to days. So then you'd have 610 times 0.03, and let's say the days were the 250 over the 360. Okay. So then I just want to show you how would you calculate that. Okay. So to calculate that, I would just multiply straight across. That's how we multiply fractions straight across. Then on the bottom, this has a 1. This has a 1. So really, you're just dividing by 360. So I would say you've got 610 times 0.03 times 215. And then you would divide that by 360, and we get 10.929166667. Yeah. And then if I do this 610 times 0.03 times 215, I do enter, and then I divide it by 360, I should still get the same thing. See, I do. Okay, and then let's say I round that to the nearest cent. Let's just say round to the nearest cent, which is hundredths place. If they say round to the nearest cent, that's the hundredths. tenths, remember, tenths, hundredths, and then look at the neighbor. Is that neighbor 5 or more? Yes, it is. So add 1 to that. So you have 10.93. Okay. Okay, and now, yeah, and I think it's best to do that. The other thing I was going to see is sometimes I see if this is terminating or repeating. Sometimes if this terminates, let me just see if it terminates. 215 divided by 360. Oh no, that doesn't terminate. See all those twos? It's messy. Yeah. If it doesn't terminate, then definitely do this route. 610 times 0.03 times 215 divided by 360. Sometimes this value terminates, and then I put the terminating value there. And I do this times the terminating value. But you see, this doesn't terminate, and you do not have permission to round off and chop this off, because then you have rounding error. So you don't want to do that. Okay. So like this terminates 610, this terminates 0.03. This is not terminating. So it's repeating twos. Yeah, so stay away from trying to convert into a decimal and just work with its exact fraction. Okay. All right. Okay. So now, what if time were 5 months? So now let's do what if time were 5 months. Okay, instead of 2 years. So you don't want to put on t times 5. If you just put times 5, you're actually saying 5 years. You need 5 months. So you need to make it a fraction, 5 over 12. So then you would apply I equals PRT. P is 610. Rate is 0.03. And then time would be 5 out of 12 because it's 5 months. So let me just see what 5 divided by 12 is. Ooh, that doesn't terminate. See all those repeating sixes? Now it terminates here at 7 only because the program can only record so many digits, but it actually continues. So that's a repeating. So then I'm going to leave it as 512 exact. So when I work with this, I'm going to do 610 horizontally straight across times 0.03 times 5, and then I'm going to divide it by 12. Okay, so 610 times 0.03 times 5, and then divide it by 12, and I get 7.625. And then if I round this to the nearest cent, that's the hundredths place. So this is tenths, hundredths. Then look at the neighbor. Is this neighbor 5 or more? Yes, it is. So add 1 to that. So I is approximately 7.63. Okay. Okay, so that's there to help you with that. Okay, just in case, because on your test you don't know when you randomly select on the computer what pops up there. You don't know if you're going to get the years or the months or the days. So we've got that ready for that. Okay. Okay. So let me do one more. I'm going to do one more problem. One more problem, number 7, which is also a simple interest problem. And then I'm going to need to take a break. But let me do number 7, one more problem with y'all right now. Let's see. Okay, so if you look at number 7, it says if this much money was paid back on simple interest loan, okay, so that's your A, capital A, and the loan, the P was $1,000, and it was C for days, 30 days. What was the simple interest rate Assume 1 year is 360. Yeah, so we're using the banker's rule on that. And what was the rate? They want to find R for that. Okay, so on 7, you need to know, I equals PRT, which you do have that here. But now you need to solve this for R, for the rate. So to solve this for R, you're going to divide both sides by PT. So I is going to get divided by PT, and on this side, the PERT gets divided by PT. So then you see here, your PTs will fall out, so you just have R. This is I over PT. See that? That's what you need. Okay, that's what you need. So if you wanted to on your formula sheet, if you wanted to, you could put that here. R is equal to I over PT, and I don't have a problem with that, because on your test you're going to have a problem like this where you're going to have to identify the rate from your simple interest problem. Okay, so I is equal to R is equal to I divided by PT. Okay, and now and then also, this is also something you might want to put down too. To calculate the interest, this is what you have to do, calculate interest. You have to take your loan's future value minus the amount of loan borrowed divided by your PT, that equals your rate. So I'm going to do this. 10% is a percentage. And now R is, the way the math books use it is they do A minus P divided by PT times 100%. Yeah, they do A minus P. Rate is equal to A minus P. So this is the loan's future value minus the amount of loan borrowed. And you see that will give you your interest. That's your interest. So the interest is how much, this is how much money. This is the, both of these equate to the amount of money charged for borrowing. Okay, so you take your loan's future value and you minus the amount borrowed. Yeah, and that's ends up being your interest. So they didn't loan you the money for free, they charged you. So that's where that comes from. So rate is equal to the interest, which is A minus P. Okay, so that might be better to put on your formula sheet here instead. Over here you can put a little side note here and put R is equal to A minus P divided by PT, and then you can even put times 100%. That way you already know you have your rate. Okay. Okay, and we have all these values. We have all these values given. So A, we have all this value given. So A was the $1,005.67. So say this was A. This was your A. $1,005.67. And then there's your P, the amount that you borrowed. Okay. And then your time, there's your time, 30 days. So 30 out of 365, which they confirmed was 365. Okay. So then when I start substituting that in here, okay, so I have the $1,005.67 minus the P, which was $1,000 over the P, which is $1,000 times the time, and the time was, how many days was that? Let's see, time, it was 30 days, right? 30 days out of the 360. Yeah, 30 days out of the 360. And then that can be reduced, and in a little bit I'll reduce that just to make the number smaller. I'll reduce that. And you don't have to reduce it if you want to work with that, that's fine, but I'm going to reduce that to make it smaller, and then times 100%. Okay. So now when there's your problem there. So now when I start, I'm going to do this in parts. I'm going to subtract this. So this minus $1,000 should be 567, right? Right. So I'll just show you 1,005.67 minus 1,000. Yeah, it's 567. And then this is times 1,000 times, that's your principal. And then I'm going to reduce this. I'm going to reduce that. So first of all, when I reduce it, those zeros right away can cancel out. So right away, these zeros here can cancel out. So basically that gives you 3 over 36. And then that can be reduced by 3. That's the greatest common divisor. 3 goes into 3. 3 divided by 3 is 1. 36 divided by 3 is 12. Yeah, so that's 1/12. That's 1/12. So this is times 1/12. Okay, and then we have times 100%. Yeah. Now, let me just see if 1/12 terminates, or does that give me a repeating decimal? What is 1 divided by 12? 1 divided by 12? Oh, no, that's repeating, yeah. So just leave it. Work with the 1/12. You do not have permission to terminate that because you have round off error when it's long repeating like that. So just leave it at 1/12, okay? All right. So now, when I type this in, let's see. Okay, I should be able to do this. So remember we talked about this key right here? Remember, this would be probably a good problem to do that on. So let's do this key right here, hit this ND key, and you should already have that set up. If you don't have it set up like that, then you need to change it on mode. You need to make sure this is on math print. So use this down arrow to go down here, and then use the side arrow to go here, and then hit enter to make sure it's on that math print. Oops. Okay, so I have 2 of them now. Let me just clear this. Okay, so let me go back and clear that. Okay, so now I'm going to do 5.67, and then I'm going to push this little arrow, see, down. And now down here, I'm going to do 1,000, and then times, and then 1 divided by 12. So let's see, probably here, if I wanted to, look, I probably could do this, right? See that? And then do 1 divided by 12. That's pretty cool. And then if you need it to put more numbers, like we're technically done here, if you needed to, you could push this arrow, see that, and push this arrow, and you come back out here if you had something else out here, +1 or something, or actually, look, we do times 100%. So actually we do, I could do times 100, and don't put the percent sign. That means that your answer is in a percent. So don't put the percent on there. It's times 100, and then hit enter. Let's see what we get. So we get 6.804. Now you put the percent there. Yes, and that does match what I have. Yeah, it does. Okay. So that'll work. Yeah, but I would do a little bit, like I did this on my own here. And then I did reduce. If you didn't want to reduce, let's see. If you didn't want to reduce, you would have this indie key to start again. And then you have the 5.67 on the bottom. You have 1,000. And then times, and then do that indie key again. And then you'd have 30 over 360 if you're concerned about reducing that. Then push the side arrow, push the side arrow. See, now out here you have times 100. See, we still get the same thing. Okay. Let's see, if you didn't use this key here, let's see, start off like this, 5.67, push this down, 1,000 times. Let's see if I didn't use that key. What if I just did, times 30 divided by 360, and then come out here, and then do times 100. Let's see that. So we get the same thing. Yep, so we get the same thing. Okay, all right, so hope that helps for that problem. And let's see, what were we supposed to round to? They said on number 7, they did say to the tenths, round to the tenths. This is tenths place. And look at the neighbor. Is that neighbor 5 or more? No. So we're about 6.8% there. Okay. Yeah, so then just keep in mind that we use days. If they had said, you know, months, then remember here, if they had said it was months, like 3 months or 5 months, you would have had to put the months over 12. So here you have to put the months over 12 if they had said months, but we were given days. If they had talked about years, then like 6 years, you would have just put times 6 there, okay? But just be careful with that, right? And like I said, you're allowed to write, if you're watching this review, you're allowed to like write that formula and put any little notes that will help you for that. And of course, when you show your work, I'm showing my work on this paper, but you also have room here when you show your work. If you want to show your work on here, you can, because you can use this while you're taking the test. So you can decorate this and show your work on that to also help. And if you don't have a printer and you're not able to print this out, then you're working on your own paper and uploading that, okay? All right, okay. All right, so then let me take a little break, and then when we come back, then I'll pick back up with number 8 then. Okay, so we have 20 problems to show you. So we're almost like a third of the way done, okay? So we'll stop there, and I'll see you in a bit. Okay, bye.